This is a continuation or part 2 of 5.3, comparing and ordering fractions and decimals. Now, hopefully you've watched the previous 5.3 video on a review. It was a review of mixed numbers and improper fractions. So please make sure you've watched that video before watching this video. So if you need to get out of this video, go ahead and do that. If you need to set up your page, you should have your math journal with you, or you have a graph sheet of paper and you're writing everything in pencil as I have here on the screen. You can go ahead and set up your page and pause the recording as you need to. So I'm going to continue. Now again, this video is dependent on you watching the previous one as a review of mixed numbers and improper fractions. So I'm going to assume by now you've watched the video and you're familiar with mixed numbers and improper fractions, and I will introduce decimals here in a second. There are ways in which you can compare and order fractions and decimals. So I'm going to go over 3 ways and just be familiar with all 3. And note that you have to be able to do this without a calculator, okay? So the first method is using decimal benchmarks. And that's dependent on the use of a number line. So now I'm going to also write down, don't use a calculator. And also, I don't want you to have to convert to a common denominator. You may have to convert to the similar form, and I'll get to that in a second, but there shouldn't be a need to convert to a common denominator, and we'll review that too if you don't remember. So if I gave you a list such as this, I want you to order the following from least to greatest using a number line. So let's say we've got 2 over 11. Okay, so now you've also got a mixed number here, 2 3/8. Okay, another mixed number, 1 and 1 over 16. An improper fraction, so let's say 14 over 9. And then finally 14 over 15. Okay, so you've got those 5 there that you have to order from least to greatest. Now, I'm going to use decimal benchmarks, fraction benchmarks on decimals as well, thinking about that. But what I'm going to do is I'm going to use a number line that's dependent on fractions where I know I'm familiar with the decimal conversion and they're easier to work with. Now, you may pick something else, which is fine, but I'm going to set up my number line like this. And I'll take you through the thinking process of how you look at it. Okay, so I'm going to have 0 here, and I'm going to just mark the whole numbers. So I'm going to mark 1 here. And I'm going to mark, this might not be exact, but that is okay. Actually, I'm not going to mark 1 there. No, I will mark 1 there. I'm going to mark 1/2 here. Okay. And then I'm going to mark 2. Again, mine might not be exact, but that's fine. Okay, here, I'm actually going to mark 1 and 1/2 here. Okay, so notice I'm working with halves or a denominator of 2. I'm going to mark 3 here, and then I'm going to mark 2 and 1/2 there. Okay, now I know my number line isn't going to continue, but I'm just going to leave it at 3 for now. Now, knowing that, I'm looking at all of these fractions and just a few things that are challenging. So number 1, they're all over different denominators. Still possible to order them though, but it's not going to be exact, but we can order them. And secondly, we have a combination of improper fractions and mixed numbers and proper fractions or regular fractions. So what I'm going to deal with first are sort of the regular fractions, because I know I can order them pretty well, okay? Now, I'm going to look at the first one. So I'm going to look at 2 over 11 and 14 over 15. Now, why did I pick those 2? Well, I picked those 2 because I know they're both less than 1, because the numerator is less than the denominator. if you think about 2 over 11, think about what it's closest to that you can estimate. So I think to myself, well, it's pretty close to, 2/10, right? So 2/10. You know that's going to be less than a half, and you know it's going to be, close to 0. So why not place it maybe about here? And again, it doesn't have to be exact, but I know approximately that 2 over 11 is going to be there on the number line. There's nothing here listed that's smaller than it, so I know confidently that's probably going to be about there, and that's fine. So again, you're using your estimation, you're using your benchmarks. Now I look at 14 over 15. Okay, 14 over 15, it's pretty close to 15 over 15, right? It's pretty close to the whole. So I know that it's probably fair to place 14 over 15 maybe here. Again, it's not going to be accurate or exact, but I'm using my estimation strategies and I'm using my benchmarks because I know it's close to the whole. So now we've taken care of the two fractions that are proper and they're easier to deal with. Now, you know what else is easier to deal with? It's easier to deal with the two in the middle because with a mixed number, it's easier to see where the whole is, right? What I mean by whole is the whole number. So let's look at, let's look at 1 and 1/16 first. So if you look at our number line, 1 is marked there. 1 and 1/16, if you think about it, it's like the whole number is 1. 1 over 16 is not a very big fraction. So is it going to be close to 1.5 or is it going to be closer to 1? Well, I think it's going to be closer to 1 because, again, that fraction of 1 over 16, it's not that big. So I'm going to place 1 and 1/16 here just after 1. Again, because the whole is easier to see. The whole number is easier to see with a mixed number. Okay, now I have 2 and 3/8. Where is that going to go? Well, okay. I'm thinking to myself, okay, I know for sure it's going to be over 2. And that's where it is on the number line. It's going to be over 2. So the question is, where does it land? Is it going to land here, or is it closer to 2, or is it going to land closer to 2.5? Well, I'm thinking to myself, okay, that 2 is fine. We've taken care of that. We know it's going to be over 2. But 3/8, actually, when you think about it, it's pretty close to 4 over 8, right? It's just one off, which means 4 over 8, if you reduce it, is actually 1/2, which means we could probably put 2 and 3/8 pretty close to 2.5 because it's close to 2 and 4/8. So I'm going to put that there, 2 and 3/8. Okay, so we've taken care of 4 of them. Now we need to look at 14 over 9. To me, I like dealing with the mixed number better because it's easier to see the whole number. So I'm going to take 14 over 9. I'm going to take 14 over 9. And I'm actually going to convert it to the mixed number. So I'm thinking to myself, okay, 14 divided by 9 goes in approximately once, and then the remainder is 5/9. So it's 1 and 5/9. Okay, 1 and 5/9. Where is that going to go? Well, I know it's going to be 5 over 9 is over 1/2, and I know it's going to be around 1.5, but over that. So just here would be good. So 1 and 5 over 9. Okay, so right there. So that's how we order using decimal benchmarks. Okay. Now, the next method or way to compare and order fractions and decimals is equivalent fractions. So now equivalent fractions involve converting to a common denominator. Okay, so equivalent fractions. Now, if you want to do this on your own first before checking order from least to greatest, you may go ahead and do so. This one you're probably most familiar with, but it does involve finding the common denominator, the lowest common multiples. So let's go with 7 over 8. I'm going to give you 9 over 8. I'm going to give you 1 1/4. I'm also going to give you a decimal this time. So now the tricky thing is the following. There's two things at play. Number one, you've got two fractions that are over 8 and one fraction that's over 4. You've also got a decimal. So how are you going to deal with that? Well, I know that the common denominator here is going to be 8. So I'm going to take 1 1/4. I'm going to take 1 1/4 and I'm going to convert that to a fraction over 8. So I know I'm going to multiply both the numerator and denominator by 2. So that's going to become 1 and 2 over 8. To make it a bit easier even beyond that, I am also going to convert this to, to the improper fraction because these two are, well, 9 over 8 is in the improper fraction, so it's easier to look at. So I'm going to go 8 times 1, which is 8 plus 2, so I know it's going to be 10 over 8. Okay. 75 over 100, I can do this. So, and I can convert it to a mixed number or an improper fraction. So what I'm going to do is I'm going to take 75 hundredths, and I know that 75 hundredths is 75 over 100. Okay, so then I'm going to convert this. What I'm going to do actually first is I'm going to reduce this so it's over 4 because it'll be easier to get it over 8. So I know that I'm going to take the numerator and denominator, divide both the numerator and denominator by 25 to get it reduced to 3/4. And then I know I can convert it to something over 8, which is 6 over 8 because I'm multiplying the numerator and denominator by 2. Now, it's kind of messy, so let's just rework this. So we know, I'm just going to rewrite everything down here. We'll do it in a different color so we know. So we've got 7 over 8. We've got 9 over 8. This equivalent here, the 1 1/4, has become 10 over 8. And then the last one is 6 over 8. So you were asked to order it from least to greatest. Okay, so we know that the least one is going to be 6 over 8. We know the next biggest will be 7 over 8. We know the next biggest after that is 9 over 8. And we know the last one is going to be 10 over 8. So I like to keep it back in its original form. So to order it from least to greatest, we know that the least is going to be 75 hundredths. And then it's going to be 7 over 8. And then it's going to be 9 over 8. And it's going to be 1 1/4. So that's our answer to that. Finally, the last method, and this is where you can use your calculator. If you don't have to use your calculator, even better, is using decimal place value. So decimal place value, and this is where you're using a calculator. And you need to order from least to greatest. Okay, so I'll give you different ones this time. So again, pause the recording if you want to figure it out yourself. So let's do 7 over 4. Let's do 1 6/10. Let's do 1 4/5. And then let's do 1 25 hundredths. And then let's do 1. Okay? So again, how would you order these from least to greatest? Well, converting them all to decimals will probably help. So again, you can use your calculator. If you don't need your calculator, that's fine. 1 and 25 hundredths and 1 6/10, they're already taken care of. So it's just a matter of looking at 7 over 4 and 1 4/5. I'm just going to do it off to the side here. So 7 over 4, convert it to the mixed number. It's easier to figure out. So I know it's going to be 1 4/5. Or you can do this on the calculator, 7 divided by 4. So I know 4/5 as a decimal is 0.8. So again, you can check with your calculator. The equivalent decimal is 1.8. So that's 7 over 4. If we take the other one being, oh, sorry, I did this wrong. I totally did this wrong. I'm going to correct myself. Okay, so 1 4/5, sorry. 1 and 4/5 as an equivalent decimal is 1.8. We know that because the whole is 1, and then 4/5 as a decimal is 0.8. Okay, you can also figure this out on the calculator and do 4 divided by 5, but by now you should know the fifths as decimals. If we take 7/4, convert that to the mixed number, that's 1 3/4. You know the equivalent decimal is going to be 1. 3/4 as a decimal is 75 hundredths. Okay, so now you can see how they all play out. So again, those two are converted into decimals, and to order this, go back in pink here, from least to greatest, you know that 1 is going to be the least. Okay, and I'm just going to use the less than or greater than signs here. So I know 1 is the least. I know that 1 25 hundredths is going to be the next biggest. I know after that is going to be 1 6/10. And then I look at my work to the side here. I know it's going to be 7/4 because that's 1 75 hundredths. And then finally the biggest is going to be 1 4/5, which is 1.8. And that's how you order. So those are the 3 methods. Using decimal place value, you can use your calculator, but I encourage you to try and not use your calculator for that. You can use equivalent fractions, which is dependent on converting to a common denominator. And then finally, the last one that we worked, or the first one we worked on was benchmarks. So using like a benchmark that you know and you're familiar with in terms of the conversions, but you're not actually converting over a common denominator.